Okay, so once you have the setting, we're going to put our decision variables because that's how many pounds of feed, like how many pounds for each of the feed we should have. So I would like to just put them somewhere here, or we know that later we're going to do the total cost. So just try to select this entire row here. I'm going to move it a little bit down. Or so either way, we can move this down. So like separate this two sections. One section is those ingredient requirement, another section will be like how many to put in each feed and the cost. So let's. I'm going to just move this down a little bit for now, and then so I have a space for those ones. So I want the feed cost. Okay. And then I'm going to move this part back. Okay, now these will be my decision variables representing how many pounds to put. Okay, so those are my decision variables, and then we can do the objective function here, total cost. And that would be sum product of your decision variables and the unit cost, right? Sum product. Decision variables and the cost. Okay. Yeah. So it's the sum product of your decision variables row and the unit cost row. Done? Okay. So then we'll do we'll do this here. Count contains. And those are like the minimum requirements. So the pounds contained in the feed for the cons, we basically can, okay, so we'll just do first the formula. So again, the sum product of your decision variables row and this row here. And this one I'm trying to represent this constraint here, the left hand side. Some product of the percentages of corns in each feed and the decision variables, how many pounds we have for each. Okay, so that's the left hand side. And later we want to copy this down, so we're going to fix the decision variable row, or fix the row number for the decision variables. And copy this all the way. And clicking the last one to check if it's correctly copied. Everyone's done. Okay. So that's our left hand side. And the right hand side, last time we said, okay, once we use the percentages multiply the pounds, the unit will get its pound. So here it's 20%, but it's 20% of the 8,000. Okay, so here then we need to calculate that. So we need the minimum. And we also talked about, there's one way to do that is use the pound here and divide it by 8,000. Remember that part? We can do, what we can do is use this one, divided, okay, I'll just put it here for now. Okay, so let's say this is the total, 8,000, okay? And one way to do it is we calculate how many pounds of corns do we have by using this sum product of the percentage and the decision variables. And then we say, okay, let's divide this 8,000 here. Then that gives us the percentage of corns in this mix. And we'll let that percentage greater than or equal to the 20%. Okay, but we talk about there's a problem for this on Tuesday. You guys remember what the problem is? If we use the sum product of these two represent the corns in the feed, and how many pounds of them, divided by 8,000 pounds, that gives us the percentage of corns in the mix. And then that can be our left hand side. Should we try that? Remember what's the problem? No? Okay, let's try this.
It wouldn't be linear.
What's that?
Was that going to be the problem with the two different size?
The gap, right? Okay, we can try this for now, see if it gives us the problem. Okay, so the 8,000 is the total. So I'll just copy this down now. Oh, sorry, I didn't fix the. So J file, I'll fix it. F4. So this represents this way. We calculate those different ingredients in pounds and divide it by the 8,000 to calculate their percentage and to make them greater than or equal to the minimum part. Okay, and there's another constraint, which is the total of your X1, 2, 3, 4 or F1, 2, 3, 4 need to be equals to 8,000 because that's the total pound. Okay, so that should be somewhere here, but my total cost is taking that space, so I'm going to move that a little bit. Oh, here. Yeah, still need to move this down for one row and put the total cost here. You know what? We can put the total cost here. Still does not look good. Okay, then like total pounds. So here is the sum of your decision variables. We want the 4 feeds total 8,000 pounds. This is demined. So that's basically just the sum of your decision variables. That need to be equal to or greater than or equal to 8,000. So that's the left hand side. That's the right hand side. These are the right hand side. Okay, so we can try. Now the setting all done. We can try go to solver. adding the objective is to minimize the total cost. Okay. Variables are the decision, are the ones shaded yellow. Keeps getting notifications on. And the constraints. So all the percentages. Oh, okay. I need to go back to change it. Originally, we want to do pounds. So here's a percentage. So the percentages need to be greater than equal to those minimum requirements. Make them non-negative. LP.
So we have, you can use the 0 and the total weight, the 8,000 for their constraint.
Oh yes, yes. Thank you, thank you. Yeah, this one. Yeah, I was too eager to see that problem showing. Forgot that one. Okay, so add another constraint. Yes, so the total weight need to be greater than equal to, or just say equal to 8,000. Okay, now we are right? We have the two. Okay. Okay, this one worked. See if any of you had a problem. I'm going to put like a percentage. Did none of you have problem? Or all solved? Okay. And like the conversion software is getting better. Okay. Let's see. Did you get the wrong arrow? No, this time worked. Okay. Okay, so we did in this way, and the other way to do it, or the preferred way. You can basically just make a copy of it, okay? Click on the sheet, do move or copy, create a copy. So this is the way to copy the entire spreadsheet and the software setting. If you copy in this way, you copy here. If you just like do a copy of the form and paste on the new sheet, the software won't get copied. Okay. So this is the way to copy your like some of your homework. It has like a part. It asks you, okay, what about you change this one? Then you can do this way, copy a new, make a new copy of it. Just change the software, and so you have the A, B, C, D questions on different sheet. Okay. So create a copy here. So now I'm going to do the preferred way. Pounds in mix. Okay, so in this one, we're going to do the preferred way, which is we calculate the pounds of corns, grains, minerals. So I'm going to delete the divided by 8,000 in each of those three cells. So the pound is only the sum product of your decision variables and your percentages. Okay, then these ones will no longer be the right hand side. We're going to calculate the pounds here. So equals to be the 8,000 pounds times all the percentages here. And we're going to fix this J5. So F4. Okay. So my formula here is changed to just the sum product of decision variables and the percentage column, and my right hand side becomes those ones, the actual pounds. Okay, then you can go to solver to see, or just to check if okay, so everything should be the same. So this one, I10, I think okay. Okay, so for this specific constraint, once I move this column, you see solver moved it for us. Originally was a J column, and when I moved this column, solver automatically updated it in the setting. So I just need to go into change this back. So greater than equal to, this column should be. Okay. And nothing else we need to change. Okay, should give you the same result. But we say like this is the preferred way. I think like the new versions of solver, they get improved much, so the scaling problem does not happen a lot. But that's still something we need to keep in mind. Those big I mean, it's random. Those big numbers and the small number, the gap cause the problem. Okay, so now let me ask you to look at this problem to see if there's any constraint that we can remove that will not affect the result. Take a look at the model. Is there any constraint that we can remove that will not affect our result? We have 4 constraints. Is there any one that we can remove? The top one, the total weight. We probably cannot remove that one, right? That's a hard constraint that they have to meet. What about the second one? So the corns in feed 1, 30%, 5%, 20%, 10%, and they need to meet this 20% requirement. Sam?
Can you get rid of the metals since it's going to be above the...
Okay, this one, right? So for the minerals, the requirement is they have to have at least 15%. And if you look at in all the feed, the minimum is 20%. So this constraint, we don't really need to have it. Okay, we can test remove it and it will still be the same result. So that's called a redundant constraint. Okay, redundant constraint is one that will not play any role in the result. Okay, and when next week when we talk about solving LP problems, we'll emphasize on that too. If you have a redundant constraint like in your homework assignment or exam, you can still write it out, and you can say, okay, that's redundant. If you use or use not, it doesn't matter. I usually give bonus points if you do identify a redundant one. Okay, but do write them out. Okay, so that's this problem. And the next one we're going to do is we're not going to do the newspaper ads problem. Okay, we'll do this one first. That's the renting the square one, the renting some space. So in that problem, we defined our decision variables as square feet of space rented in month I for j months. Okay, and the cost for 1 month lease is 55, 2 months lease 95, 3 months, 4 months, 5 months lease. Those are the unit lease here. Okay, and for each month, those are the requirements. Okay, so I'll ask you to think about this one and design your spreadsheet yourself first. See if there's a good way of designing them. Hope you still have your notes with you. And we said it doesn't matter if you highlight all of them as your decision variables. We just know that we won't, when the problem is solved, we just won't use the others. Because it doesn't make sense to rent 5 months when you are in the 5th month. And the cost will cause solver to not select it anyway. So I'll leave this here. So because this is like in which month we lease them, and this is the cost. So my cost is good. I'll just So I'm doing my objective function. The total leased is sum when you do the sum total cost, then you will do the sum product of the cost. Then I'll see if you guys have a creative. So my total cost is the sum, not done, sum product of the total leased and the unit cost. So that's the total cost part.
Can you go back to?
Yeah, that's a, and when that's the part I think you all got it. That's just the objective function, and the total cost is the total list is basically the sum of the column here. Okay, and then we'll take care of the constraints. So in the constraints, each month. Remember we did this where we're going to do a cut and we're going to do a transpose. Please special. Come on. To transpose.
Yeah, like you summed it.
Yeah, but
It's just like a
yeah, let's take a break. I'm gonna get a new.
This is not a break, it's me catching up.
Then you can.
Add another row here. Need to add another row here. Okay. I'll do this quickly. So if you are not done for it, and if you are done, keep thinking about. There's a simple way of for doing it in spreadsheet if you redesign your Excel. I mean, you redesign your decision variables. Okay. So for this one that we decide. So the total cost, those are just like the sum in each month, actually, the length. And then we take care of the decision variables, then objective function. Now we're going to do the constraint. So for the constraints, we need to meet those certain requirements. That's my right hand side. Okay. And here I'm going to do square feet or space. Space least. One common mistake is you use this part, like the square feet least, and put to make them to meet the needs. But those ones we calculated are only say, okay, how many square feet we lease for 1 month? How many we lease for 2 months? How many we lease 3 months, 4 months, and 5 months? Okay, so those only represent how many we leased for how many for each of the lengths. And here for each month we actually need to come this way. So the first one, to meet the first month's need, we can use all the square feet that we leased in the first month. So that's the same with this one here, but what we're going to do, put it here. That's for the first month. Okay, then in the second month, first we'll use the ones that we leased in the second month. Okay, but don't miss the ones that carried through from the previous month. So we need to add the ones from the first month, which start from. So it's this one and this one. So these two.
I still have everything.
Okay, so that's to meet the need for the second month. Then in the third month would be what do we need from the third month plus those carried over from the second month. So every time you need to shift one plus the ones from the first month would be, let me see, here. Now it's these three here, these two here, or these three here and these three here. Okay. So to meet the needs in the third month, you have some carried over from first month, second month, and the third month. So the formulas we put here, they really cannot be copied. Plus sum from the previous month. Got two of them. Plus sum of 1, 2. Yeah, we'll shift one cell every time. And then the last one would be this one plus this one plus this one plus this one plus this one. Okay, if you get the idea, you should be able to fill all of those, the left hand side. Okay, then we have our left hand, right hand side. And that's it. We'll go to define them. Objective function. We want to minimize cost variables. So I can select the entire thing. Okay. Constraint will be all the square feet leased need to be greater than or equal to. So in this one, it's better to use greater than equal to, not equal to, because we may not be able to find the way to make the requirements exactly equal to every month. Okay, we can let's try equal to, see if it works. Make it non-negative. Okay, so this time it did find the solution. So that's $7 million. Okay. And this is the model that we built using this way of defining square feet rented in months for J months. So what's a different way of defining the decision variables in this problem? Can you think about different way of defining the decision variables? Any thoughts? Rented in months I for J months. Can we do square feet that we rent in I months that goes to J months?
You're talking for summation?
What's that?
Are you just talking the summation?
No, still the decision variables. So we can still do Xij, but instead of saying square feet rented in months I for J months, so J represents the lease, the length of the lease. We can do say square feet rented in months I through months J. Okay, if we do that through months J, what does the X 23 mean? Means the square feet we rent in second month that goes to third month. So what kind of a lease is this? 1 month, 2 months, 3 months, 4 months, 5 months?
1 month.
A 1 month lease. Okay, so in this definition, this J here represents the length of the lease, but here it's okay how until which month it goes through. Okay, and this way, everyone got this? Okay. Then make a copy of your spreadsheet, or actually you don't need to make a copy. I'll ask you to formulate in this way on your spreadsheet. You use this definition here. So I'll show you the new definition. It's rented in months I through months J. So the formulation here will be different. The decision variable will be, the objective function will be more complex than the other way. Okay, we choose the other way because it's easier to write the objective function. And the constraints are similar. Constraint will be the same. Okay, but I'll tell you in Excel this is easier. Try this. Try this. You will still use the matrix. Square feet rented in months I through months J. So we'll still months 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so those are still your decision variables. So we're going to rent. So the first one is still the same. So you're going to do the x11, this is x12, x13, x14, x15 through month 5, okay? And then 2, you will do x21. Oh, sorry. Do we have x21? No, we don't have x21. We're starting from the second month. Okay, so we have x2, 2, right?
Yep.
Okay, then x23, x24, x25 through the month. Okay. Similarly, we won't have x31, won't have a 32, but we're starting here. x33, we rent in the third month that goes through the third month. We rent in the third month goes through fourth month, goes through 6 months. 4, 4, 4, 5, and x 5, 5. Okay, so that's the new way. And try this in Excel. Let me go to my Excel. Okay, so that's okay, so those are all months. And we're going to shade them different way now.
Okay, good. That makes me feel a lot better.
Oh, I have this mouse here now. Okay, so let's see which ones help us to fulfill the first month. First month is the sum of the ones that we rent in 1 month through all the different months. Then the second one, which ones help us to do the second month? That goes through. Oh. Okay. Some of those ones plus. Okay. I think it's pretty similar, but it is a little easier. It's like you don't have to shift your cells. So similar way of thinking. Objective function, we'll take care of that later. We'll look at the constraints. Constraint, the first month is the same. Those ones that help us fulfill first month's requirement are the ones that we rent from month 1 to all the different months. Go through that. Okay, so it's like a from, here is like a from month to, those are the 2 months. So the first one is the same, the sum. And the second one is the sum of what you rent in this month, so the second month. So those ones that you rent from the second month that goes through the second month, go through third, fourth, fifth. And then plus basically these ones. So it's the ones that go through the second, third, fourth month. So you don't have to shift this cell at shift this month. In the previous one, we have to shift it 1 month. But here you can see we'll just keep going. It will be the sum of these 3 and sum of these 3 plus sum of these 3. So it's these 3, and these 3. So they all go from the third month. So it's all the ones that fulfill from the third month and all the way to 4, 5.
Could you just highlight like all
The entire box. Yes, you can. Yes, you can. Good question. Yeah, so yeah. Tanner asked, so for example, this one, it will be easier. We'll just highlight, okay, the sum of this entire box here. Okay, so that's why it's a little easier. So it's this box here, and then in the third one, it's just this box here. Okay, and then the third one, it's this box here. All the ones, so it's like we have the to meet 4 months fourth requirements, we highlight all the square feet that rented to the 4th month and after. So every month we just use the square feet that rented from the current month and after. Make sense now? Like you go through this month and all the months after will help you fulfill the requirement here. So the last one would be the sum of this column here. So that's all 5th month's requirement. Okay. Then we can just copy the then the cost will be different. We'll put the cost here. So now, how to calculate the total cost?
You're gonna go like diagonally.
Diagonal? Okay. So like this one would have to be the sum product of which ones?
1, 1, 2, 2, 3, 3, 4, 4, and 5.
So it would be like this one multiply here, right? And then so those are the 1 month. So would be we probably have to calculate another one. Well, we'll do it's the same with the previous one. We have to have another column that's so square feet rented for each lease type. Okay. So now this one will have to go. So if it's a 1 month lease, then it's 1 month lease, 1 month lease, 1 month lease, 1 month lease, then 1 month lease. Okay, and then you do a 2 month lease equals to be the 2 month lease. This one plus this one plus this one. So it's all go by diagonal. Then 3 months lease is this is 3 months here, this one, and this one. 4 months lease, this one plus this one. So this way is more like you can see the the rules, underlying rules better. There's just like pattern, you just follow the pattern to go. Okay, so that's why I think this way may be easier. But intuitively to think, I prefer the previous one.
Yeah.
You prefer the previous one too? Okay. Okay. Okay, so the 5 months lease is this one. Okay, then we do the sum product. Sum product of these ones and the cost. Okay, so that's it, and we'll just go to solver and define it. So the objective is to minimize this total cost. Variables will be, we can highlight all of them, and constraints will be again space leased greater than equal to space required. Okay, non-negative LP. So okay, so we got the same result. Okay, so now we'll just do one more formulation and we'll be done. So this one we're not going to implement in solver. Okay, we'll just ask you to do this formulation. Or if you are still working on the model, we're gonna finish, but we can think about this problem too. Then we're done for chapter 3. One milestone. Okay, so let's take a look at this problem. Oh, not ILP, sorry, it's LP problem. So the problem is to minimize the number of rows it's used to fill the order. And they want 400. So 400, let's see how can I put it, 12 inch, 318. 224. So that's the requirement. And what they have is 40. So they have this 40 inch. So how do they fill this order? They cut the 40 inch rows, right? And how do they cut it? How do they cut this? They want to have 18, 12, and 24 inch rows. So what would be the first step?
Like what are other options of how they could cut it?
Okay, the first step, look at all the different options to cut it. Okay, good job, good job. So how do you do that? The 40 inch, what's the first one? First way to cut it. If we just look at the 12,
12 plus 12.
12, 12, 12, right? Okay, what about the second way? 12, 18. Okay, no more.
24.
24. And which one? 12,
18.
18, 18. Okay, that's all of them, right?
That's 24.
What's that? Just 24, okay, included here. Or just the 12? Okay, so those are the ways, okay. And then, what's our decision variable then? Number of rows to cut in each way, right? Okay, so we'll say x1 is so that's our pattern, okay, or our pattern. So our decision variables will be xi representing number of. Can you see if I write here? Number of rows to cut in pattern I. Okay, and then we'll look at, okay, for example, if we cut it in pattern 1, how many 12 do we get? We get 3 of them, right? If we cut in pattern 2, we get 112 and 118. And we cut in pattern 3, we get 124 and 112, and so on. And to fulfill this 400 here, which ones help us to fulfill the 12 inch rows? The x1, and how many do we get? When we cut each row in pattern 1, we get 3. Oh, probably I should still leave here. That's the 12 inch, okay? And this is the 18. This is the 24. That's right? Okay. Every one row that we cut in the first pattern, we get 3 12-inch rows. Okay, so that means we need to multiply 3 here. Okay, so every one row we cut in pattern 1, we get 3 of them. Plus, if we cut any in pattern 2, then we got 1 row. Okay, so plus x2. So any row cut in pattern 2, we gain 112. And the same here. Any row we cut in pattern 3, we get another row here. And so these would be the rows that we have in 12-inch. We'll make this greater than or equal to 400. Okay, so that's the 412-inch rows we will get. Okay, now let's write that for the 18-inch row. Someone can write this for me? To get the 18-inch row.
X2 plus 2x4.
X2 plus
2x4.
2x4. Okay. Okay. And then for the 24, basically it's just x3, right? We're going to equal to 200. Okay, and then we'll make all the xi's greater than equal to 0. Okay. So this is one problem that we need to do some analysis, enumerate the different ways of fulfilling the order, and then we define our decision variables. Okay. So far, though, many of those problems, like the decision variables, are pretty obvious. We already know, okay, what they are. But like in this specific problem, we have to enumerate the pattern first and then say, okay, the decision variables are corresponding to how we cut them. Okay. Any questions? No? Okay. Okay, I'll see you next week then.
What was the OF?
I want to see you more. But you all look well done. Yes. Object function, we want to minimize the row cut. Yeah, thank you. So minimize sum of xi. 1 to 2. Okay, so that's a simple object function. Thank you for asking.